Okay, so now we're going to use the calculator. And so you want to make sure your calculator is in degree mode rather than radian mode. So there's two different ways to measure angles. One of them is radians, one of them is degrees. As you can see on the screen, I had originally had my calculator in radians. I got a negative value for that, which is measuring in radians. We're supposed to be measuring in degrees. So the sine of 30, when you put in 30 as a degree, is 0.5. Radians versus degrees is similar to inches versus centimeters. There's two different ways to measure angles. So the sine, cosine, tangent buttons on a graphing calculator are in the middle of the screen. So I'm calculating the cosine of 30, which rounded to 4 decimal places is approximately 0.8660. And I'm writing approximately to indicate that I have rounded that value. The instructions in the problem said to round to 4 decimal places. The tangent of 30 is approximately 0.5774. Now remember that the sine of 60, we can type in the calculator and get 0.8660. But remember that we can use what we know from before. Cosine of 30 is the same as the sine of 60, and the cosine of 60 is the same as the sine of 30. So the cosine of 60 is 0.5. Now for the tangent of 60, so we can use the reciprocal of the tangent of 30. So if you typed in tangent 60, you would see it's 1.7321. Another option is to type in the tangent of 30 and use that button right there, which is the reciprocal button. X to the negative 1 will take your number and flip it over. So if you typed in the tangent of 30, got that value, and then hit that x to the negative 1 button, it'll take that previous number and flip it over. So it's going to give us 1.7321. So two different ways to get the same value. I want you to notice that what we just calculated are the decimal approximations for the problem that we did above. We found exact values for the 30, 60, 90 triangle. Angle M was a 30-degree angle. Angle N was a 60-degree angle. So we found the exact values as fractions and radicals, and then we used our calculator to approximate those fractions. So for example, if you type in square root of 3 over 2 into the calculator, you'll get about 0.866. Now that's rounded, so it's not going to be the same exact value. The exact value comes from a 30, 60, 90 triangle. And again, if you were to type in square root of 3 divided by 3, or 1 over root 3, you would get approximately 0.5774. We're giving decimal approximations of those values. (30, 60, and 45 are the special angles for which you can use a special right triangle to give the sine, cosine, and tangent values. So if it were any other angle measures, you would use your calculator. So you can see from the problem above, sine, cosine, and tangent of 60 could also be found. Okay, so now we're going to solve a triangle. That means find all the missing angles and sides on the triangle. Notice in this problem, we're given one angle measure and one in the hypotenuse. So we can subtract from 90 to get the other angle because the acute angles are complementary, which means that's a 54-degree angle. Now I'd recommend that you use the angle that was given when you go to decide opposite, adjacent, and hypotenuse. Just because if you made a mistake and you subtracted wrong, then it won't compound your issue. So if we start from the 36-degree angle, in relation to the 36-degree angle, we have the opposite, which is on x. The hypotenuse, of course, is the longest across from the 90, and then the adjacent leg is the third side. I'm going to write our SOHCAHTOA, our mnemonic device, just to make sure we don't forget how the sine, cosine, and tangent ratios are defined. So we're going to use the hypotenuse and the 36-degree angle to solve for x. So we're going to use sine because sine uses opposite and hypotenuse. Sine of 36 degrees is the opposite, which is x, over the hypotenuse, which is 8. Now remember that sine of 36 is just a number. So when we compare opposite to hypotenuse, we need sine of 36 and then a ratio of two things, and we don't know the variable x. So in order to solve this equation, we're going to multiply both sides by 8. You don't really have to have the parentheses here, but some people think it looks better. When you write sine, cosine, or tangent, there always has to be an angle after it. Sine, cosine, and tangent are functions, so it cannot be separated from the number or the angle that's after it. So it's really like the sine of angle A or the sine of 36 degrees. Okay, what we're typing in the calculator is 8 sine of 36 degrees. Depending on your calculator, you might have to do 8 times sine of 36. In the problem, it said to round to the nearest tenth. So, rounded to the nearest tenth, x is approximately 4.7. Now, we're going to find y also. So looking for y, we don't care anymore about our x value. We can use the hypotenuse and the 36 degrees to solve for y. So again, I would suggest that you use the number that you know, which is 8 that was given, and the 36 degrees that was given to find the y value. While you could use the 4.7 in your calculation and do tangent, for example, I wouldn't recommend that because if you make a mistake with your x, that will carry over into your y. So I'm going to use cosine because cosine uses adjacent and hypotenuse. So for the 36-degree angle, the cosine of 36 is the adjacent, which is y, over the hypotenuse, which is 8. Same thing as before, we're going to multiply both sides by 8 to cancel that denominator. Again, you don't really have to have parentheses around cosine 36. If you want to, you can. From the calculator, that's telling us that y is approximately 6.5. So we have now solved the triangle, which means find all the angle measures and find all the side lengths. Your other option is to use the Pythagorean theorem after you know 2 of the sides. So you could say y squared plus 4.7 squared is equal to 8 squared. And then that would give you the same approximation for y being 6.5. If you use the Pythagorean theorem, it might be slightly different in terms of your answer compared to using trig, but it shouldn't be significantly different. If I can tell it's different due to rounding, as long as you show the work, it's perfectly fine. The rounding difference should be very minimal. Okay, so we're going to find z again by just finding the complement to 38 degrees, which is 52. So we now have z. Now again, I'm going to use the 38-degree angle because that one was given in the problem. So the 38 was given, the 14 was given, and we're going to find the other two sides, x and y. The hypotenuse is y, the opposite is the side with the 14 on it, and the adjacent is the x. So for, again, writing our mnemonic device, SOHCAHTOA, if we do the sine of 38 degrees, we'd be doing the opposite, which is 14, divided by the hypotenuse, which is y. Opposite over hypotenuse is sine. Now this one looks different because the variable is in the denominator. So you have the choice. One option, y is on the bottom, so we need to get the y out of the denominator. One option is it turned into a proportion. Put it over 1 and then cross multiply. So y times the sine of 38 is equal to 14. And then sine of 38 is a number, so you can just divide by sine of 38 and get y is 14 over sine of 38. Your other option is to multiply both sides of the equation by the denominator y, and you'll end up at the same place. Y times the sine of 38 equals 14. Now again, sine 38 is a number, so if you divide both sides by sine of 38, that will cancel on the left side with the y. So what you're typing into the calculator is 14 divided by sine of 38. Okay, so we're typing into the calculator 14 divided by sine of 38 equals, and we're writing the nearest tenth again, so it's approximately, y is approximately 22.7. And that's the y value, about 22.7. Now we're going to use the opposite and the adjacent to find x. So from 38 degrees, the opposite is 14 and the adjacent is x. Tangent uses opposite and adjacent. So tangent of 38 degrees equals the opposite, which is 14, over the adjacent, which is x. Now again, you can turn into a proportion and cross multiply. X times the tangent 38 equals 14. Or you can multiply both sides by x, and then it would cancel the x on the right side, and you would divide both sides of the equation by tangent 38. So x would be equal to 14 divided by the tangent of 38. Whichever way you do it, it's going to come out with the same thing. So if x tangent 38 is 14, then that means that x turns into, when you divide both sides by tangent 38, and you type that into the calculator, 14 divided by tangent 38 the tangent 38 cancels, and 14 over tangent 38 is the exact value. So the approximation for that is 14 divided by tangent 38 equals about 17.9. So x is approximately 17.9. Now again, you could have found x using the Pythagorean theorem. If you found y first, you would use 22.7 and 14 to get the x value, which is the adjacent.